Hi everyone, in this video we are going to talk about the precipitation of two different ionic compounds from a system containing two ions. Alright, so in this case you have Br minus and Cl minus, right, which will precipitate out with Ag plus ions. So this question can also appear in the form of these two ions being cations, and we are adding the anion into the solution to precipitate things out. So the same concept applies. So the first thing that we want to do is to recall some of the things that we have talked about in precipitation. So the first idea that we need to recall is the fact that when a PPT is formed, all right, any additional AgNO3 added in, or rather every additional Ag plus, some of them will go into the PPT, some of them will go into the solution. So that's the first thing. The second thing is whoever's IP crosses KSP first, right, will eventually become will actually cause PPT, even if you already have uh, some solid and solution in equilibrium. All right, you will have our IP is equal to KSP. Okay, when you add in something else, momentarily IP will be greater than KSP, then you'll get more PPT, then you'll reach IP is equal to KSP again. So I pour a little bit more. At the instance I have more IP, my IP overshoots KSP again, I get more PPT, and then the system drops back to IP is equal to KSP, and so on, until the process repeats again and again and again and again until the second thing comes out. So how should we go about tackling this question? Alright, we should be able to establish both of these equilibrium. So I will just simply write down the KSP for both cases. So the first one is the KSP for AgBr, which is Ag plus multiplied by Br minus. So it's important for us to fill in these two values. This KSP is equal to Ag plus and Cl minus. Alright, so what is going to happen in both of these cases is that I am able to add in some I'm adding in my Ag plus into the solution. So in fact, what I'm interested in is the concentration of Ag plus currently in the solution, right, which will change these two values. So what you will really think of is the fact that these two values are the same values, because there's no way that I can have two different Ag plus concentrations within the same solution, right? So I hope this makes sense to you, that Ag plus and concentration is the same for both of these KSP values. And so the only variable that the only thing that determines whether it precipitates or not is the value of Br minus and Cl minus in the solution. So in different situations, Br minus AgBr might get precipitated first. In some situations, AgCl will get precipitated first. So how do we make sense of that? We just need to compare IP versus KSP. So what happens is that whoever reaches IP is equal to KSP first will be precipitated first. Okay, so this depends ultimately on the concentration of Br minus and Cl minus already in the solution. So of course, the one that requires the least Ag plus will be precipitated first. Then as we know, some of them will stay in the solution, some of them will go into PPT. So let's say, for our sake, AgBr is the one that gets precipitated first. So I have a certain concentration of Cl minus, I have a certain concentration of Br minus, and I'm adding in Ag plus. Okay, so what happens is that the Ag plus concentration in this solution keeps increasing. Right, once I keep adding in, and so both of these IP values, so the IP of AgCl will be increasing, the IP of AgBr will be increasing, right, and it keeps increasing and increasing and increasing until a certain point where AgBr gets precipitated out. So what happens at that point in time is that precipitation of AgBr will be formed. Okay, just a tiny little bit of PPT. Then when I add a little bit more, alright, my IP hasn't crossed KSP yet for AgCl, but IP versus KSP has already crossed. So because it is already above KSP, what it's going to do is the position of equilibrium will shift to the left such that it becomes equals to KSP, and we form more PPT. So as a result, this becomes bigger. So as we continue the process, it becomes bigger and bigger and bigger and bigger and bigger until the point where the IP of this is larger than KSP. Right, then we get the second PPT, which is our AgCl that is formed. Alright, so this comes from this idea that any additional Ag plus some goes to the PPT of AgBr, some stays in the solution all the way till the point where the IP of AgCl is greater than its KSP. Then it will equilibrate back and you will get some PPT. Then as I add more, I will get more and more AgCl and I will just get more and more AgBr along the way. Okay, so this is how we can tackle the precipitation of two ions. The first one that reaches IP is equal to KSP will get precipitated first. Then the second one where then the concentration of Ag plus will keep increasing to the point where the IP of AgCl is equal to a KSP and the second one will come out. So at the end of the day, all you need to remember is this phrase: IP is equal to KSP. This is what we want to do. So as long as IP is equal to KSP, that is the point right before it starts to precipitate, and this is what we are looking out for. So if you do not fully understand this, please watch the video a couple more times and eventually you will be able to understand how to answer questions in requiring you to calculate the precipitation of two different ions.